Hi everyone, we're going to go ahead and work on writing some linear equations. Our learning target for today is to be able to write a linear equation in one variable given a real world problem. So the very first thing on this first question, I'm going to make sure I know what they're asking me to do. Okay, so real world problems got descriptions. We've got to find what's important, but most importantly, what are they asking us to find? So on question A, for example 1, your gym charged you last month a fee of $30 in additional cost for the 17 classes you attended. You paid $81 for the month. Define the variable to use when you create an equation for your total bill for the gym. The only thing they're asking us to do is define the variable. So to define the variable, we need to find what's changing. So I looked at this, the gym charged you a $30 fee. Now, did that change last month? No, they charged me that. I cannot change that amount. They charged me an additional cost for the 17 classes that you attended. Could that change? Yes. Maybe I only chose to go to 10 classes, or maybe you chose to go to 20 classes. So the number of classes that you choose to attend does change. You paid $81 for the month. Did that change? No, because it's in the past, you've already paid that. So what is changing here? The only thing changes the number of classes. Okay. So given that we're looking at that, or the cost for the classes, so we're looking at this and we're trying to figure out that could have changed. So what variable could I use to describe classes? I'm going to go ahead and go with C because classes starts with C. For part B, two runners start at different points on a track. Runner A starts at 100 meters ahead and runs at a speed of 8 meters per second. Runner B starts at the beginning of the track and runs at a speed of 10 meters per second. Define the variable to use when you create an equation to find out when runner B will reach runner A. Again, the only thing they're asking us to do is to define the variable. So what's changing here? Well, hint, hint, when they say per, that would be something that tells us that that's what's actually changing. 8 meters per second. The number of seconds they run will change the amount of meters that they go. So let's go with seconds on that one. So on this one here, though, I noticed that when I write the letter S, for me, that looks like a 5. So I may not want to use an S when I'm writing an equation. I may want to use an X, okay? Or I may want to use T. But most of you will probably choose S because the word seconds starts with S. Okay, so let's go on to check your understanding 1. Here on questions A and B, I want you to see if you can define the variable for each of these. Okay, so what are they talking about? And then what variable would you use to describe that word? Now, let's go on to our next one. Okay, our goal at this point is just be able to define a variable that we're going to use. Now, once we have that variable, we're going to go on and now see what they're asking us to do here. You have read 18 chapters of a 58-chapter book. You plan to read the same number of chapters each day for the next 14 days, then continue reading the same daily amount for 6 days next month to complete the book. Write an equation to determine the number of chapters you will need to read. Now, in order to write an equation, we have to realize that something's changing and some things are not changing. They're just given to us. So we have to define that variable. So you have 18 chapters. You have read 18 chapters. So you've already done that. So whatever the total is, we can take off that 18 chapters. There's 58 chapters total in the book. Again, these things are in the past. They're not changing. You had 58 chapters. You read 18 chapters. You plan to read the same number of chapters each day for the next 14 days. So for 14 days, you're going to read a certain number of chapters. Then you're going to continue reading, but for the next 6 days, it's going to be a different amount. So a daily amount for 6 days. So what's changing each time? They're already telling us the number of days we're going to read. They're telling us the chapters we did read, and they're telling us the total chapters. So what is changing? Well, what's changing is how many chapters am I reading those 14 days? How many chapters are we reading those 6 days? Just so we can finish the book. So on this one here, I'm going to put chapters. Again, you can choose your variable. I'm going to go with the variable C because we're talking about chapters. So to write this equation, first off, think about the total. We had 58 chapters to begin with. That's our total. Well, out of those 58, what do I have to read? Well, I've already read 18. I'm also going to read 14 chapters, certain amount of chapters for 14 days, plus I'm going to read 6 more days with some other chapters there. Now, I'm trying to decide how many chapters do I read, okay? So here's our equation. This is one option. Now that I have this, I want to look at it to see if I can simplify. Is there anything that I can do to make this equation look a little smaller? On the left side, I have a constant value of 58. Constant means there's no variable with it. On the right side, I have a constant value of 18. I have two variable values, variable terms or variable values, because they have a variable with it. 14C plus 6C gives me 20C. Now there's another way to actually write this equation, and I'm going to show you that one as well. Some people see this as, I have 58 chapters to start with, but I've already read 18. So I can subtract 18 chapters. That's what I've already read. This is the past. What's in the future? In the future, I'm going to read 14 days. I'm going to read so many chapters, plus 6 days. I'm also going to read so many chapters. Okay, so now that we have these two, we can look at it and say, can I simplify this? What is 58 minus 18? Because these are both constant terms. So that would be 40. And then 14C plus 6C, both variable terms, which gives me 20C. So more than one way that this information can be presented in an equation. Okay? All right, let's go on to example 4. So you're planning a party and you have a total budget of $756. The cost of food is $12.50 per person. You also spend $156 on decorations, an additional $30 on party supplies. Write an equation. So what did we already spend and what is changing based on what we're going to spend? So you have a total budget of $756. That doesn't change. That's how much you can spend. The cost of food is $12.50 per person. There's that key word again that helps us identify that maybe something's changing here. You also spend $156 on decorations and an additional $30 on party supplies. Now, that also tells us that it's a flat fee, which means that cannot change. So to write this equation, you can either put in your expenses and then set it equal to the total, or do the total equal to the expenses. I'm going to think about what I'm spending here. So the cost of food is $12.50 per person. So we are talking about the number of people who attend. That's what's changing. That's what's going to make the price increase or decrease. So for people, I'm going to go ahead and use P. So I have $12.50 per person, or you could just write 12.5. Okay, so whatever works for you here. So $12.50 per person. Then I'm going to add the $156 that I spent on decorations. I only spend that once. And then $30, a flat fee that I had to pay for some other supplies. And then that equals the total that I'm able to spend, which is $756. So I'm looking at this and I see I have two constant terms that I can combine. So I have $12, so 12.5p plus 186 is equal to 756. Okay. That's one way to write it. I'm not saying that's the only way, but that is definitely one way that we're going to consider here. Now, on check your understanding number 2, I want you to go ahead and read this problem, see what they're asking you to do, and then find your variable and go on from there. Let's go on to example number 5 together. So example number 5, you start with $100 and save $20 per week. Your friend starts with $150 and saves $15 per week. Write an equation to determine after how many weeks will you both have the same amount of money. So with that keyword the same, that means they're going to be equal. So what's changing here? Is the amount that they started going to change? Nope, that's a constant rate. That's what they have. The amount per week they save? Yes. But again, there's that word, per. That tells us how often something has happened. So what's changing is the number of weeks. So for weeks, I'm going to go ahead and use the variable W. So person A should equal person B since they're going to be the same. So person A has $100 plus $20 each week or per week. They're going to be the same as person B, which is $150, and they add $15 per week. Now, looking at this, is there anything that I can combine? Here I have a constant term. Here I have a variable term. They cannot be combined because they're different types of terms. So that is that piece. Over here I have a constant term. Constant means it doesn't change. Variable term means it varies. So there's my variable term. Cannot combine those two. So unless I'm solving this for W, which they didn't ask us to do, here is our answer. Okay. All right, example number 6. 2 runners start at different points on a track. Runner A starts 100 meters ahead and runs at a speed of 8 meters per second. Runner B starts at the beginning of the track and runs at a speed of 10 meters per second. Create an equation to determine when runner B and runner A or runner B will reach runner A. So in that case, if one is reaching the other, that means they will be the same. Okay, so what variable are we talking about? What's changing? Well, it's per second. That's what's changing. Again, we're talking about time. Okay, so we're going to use seconds is what we're measuring. So you can use the variable S. And like I said, sometimes my S's look like 5s. This time, I'm going to choose to use X. Now, if I choose to use X, that's okay. Having a little key up here will help me remember what that represents. So when I'm writing my equation, I know. So equation or runner A started at 100 meters, and then they added 8 meters per second. Runner B started at 0 meters, and they added 10 meters per second. Okay, so now when I look at this, I'm trying to say, can I simplify anything? Does this 0 here really matter? No, because 0 plus anything keeps it the same. So I have 100 plus 8x is equal to 10x. Okay? That 0 was just there kind of as a placeholder to remind me, what was I measuring? What did they start with? They started at 0 meters per second, okay? So now we've got these ones. The last one here is for you to do Check Your Understanding 3. By the time you're done with Check Your Understanding 3, I want you to feel confident to say that you can write a linear equation with one variable given the written description of real-world context. See you in class.